I request Professor Mulligan to share her screen and present the webinar. I want to thank on behalf of all the attendees for taking time and willing to give this presentation, Professor Mulligan. Thank you so much.
Thank you very much. Hopefully this my slides will get going here. Okay, great. So thank you very much for inviting me. This is a great opportunity to get this information out to more and more people. So yeah, so I think the bio is a little bit old for what Dr. Krishna did. So currently, yes, I am the director of the Institute, but I'm also chair of the Canadian Geotechnical Society Sustainable Geotechnical Committee. So we have various activities in that, organizing various conferences, subsections in our annual conference in the Canadian Geotechnical Society. And actually, this lecture was part of a cross-country lecture tour. We did about 13 cities across Canada there. So basically, this is the lecture that was given from this tour. So I think I'm going to stop my video just to make sure that I have enough bandwidth for the presentation here so that you don't miss anything. So hopefully this presentation won't be too slow. So I just wanted to start off with the territorial acknowledgement. I'm based in Montreal, so I'm on that basis there. I'm acknowledging the territory and unceded territory of the Kanesatake, which is the Mohawk territory here in the Montreal area. And of course, I recognize that everybody is in many different places there. So I hope you recognize where you are and that we are borrowing in their lands for these purposes, in particularly in North America. Okay, so my institute is, just to give a quick introduction, basically it's a multi-faculty approach there. It's based in the Geotechnical School of Engineering and Computer Science. We work with science, the John Molson School of Business and Fine Arts. And we also have collaborations with different universities, such as the École Polytechnique, École Technologie Supérieure, and McGill, which are all based in Montreal. We have York University and University of Quebec, Abitibi-Témiscamingue, which are in the Abitibi-Témiscamingue area. And we have many, international collaborations as well. So the whole idea is to be able to have engineers learn other activities besides technical activities. So all the true meaning of sustainability is looking at the environmental, economic, and social sides there. So we try to make sure that everybody tries to get this. Oops, sorry. The thing is behaving itself a little bit. Okay. So basically, we want to, I always just start in general in terms of challenges for the environment, which I'm sure many of you guys know, but anyway, just to get the context here to begin with. And I see my internet is a little bit unstable, so please forgive me for that. So yeah, so we need to propose these long-term environmental strategies. So in the early 2000s and so on, we come up with this, we started working towards sustainability. And we said, well, we have to be able to apply this to, say, for example, for cities. If we're going to do this for cities, then we got to look at the urban area itself and the region and so on. We got to make sure that the quality of life is desirable for the community, both obviously for the present generation, but also coming in the upcoming generations after that. And so we want to make sure that we reduce the impacts in this area and within and of course outside this area. So this is kind of the sustainability conference, came from the Sustainable City Conference in Rio in 2000. So yeah, so a lot of these presentations, of course, are given in this series around the Geoenvironment. So of course, you're all very familiar with the Geoenvironment is. Basically, it's a very important resource with many elements. So to be able to make sure that humans can be able to survive. So we have specific ones in terms of the goals of sustainable development. One is to practice that we will conserve these resources as much as possible. And of course, that we mitigate any of the impacts on the geoenvironment from any of the human activities, and try to manage these impacts and as much as possible. So of course, the elements of the geoenvironment, whether we're using it for building purposes, we're using it for food purposes, using it for mining and mining various minerals for all of our electronics and so on. So obviously, the geoenvironment is very important and needs to be maintained over the coming years. So the other, besides sustainable development concepts, there are the other aspects that are becoming much more important, of course, are aspects related to climate change, which we are seeing is much more urgent. And we've seen some of the, particularly in regards to the COP27 that was held recently. So as you know, these climate change patterns have been shifting. And so really the temperatures have been slightly increasing, maybe from a degree to a degree and a half and things like this. So these, of course, will cause more and more aspects, which will cause much more issues as the time goes on. So maybe by 2052, we have about a degree and a half increase in the temperature. So this is mainly causing many shifts in the radiation levels, the changes in precipitation levels, and of course, some of the incidences of natural disturbances worldwide. So we can look at it causing, of course, not only impacts on the organisms and so on, but also on the human systems and our lives as well. So there have been different been happening. We've seen, of course, you know, so this graphic I think is pretty neat in terms of it can summarizes the different impacts as the temperatures increase. So say, for example, right now we're having the lower levels of warming, and we're starting things like the ice cap starting to, in the Arctic, starting to melt. Some of the sea levels are starting to increase. We're starting to have more severe weather events, whether it be these tornadoes and hurricanes and so on. Maybe even some increased frequency of earthquakes and things like this. And definitely some of the heat waves and some of the changes overall in the ocean temperatures. And of course, as you increase it, you will get more and more impacts. So more and more severe impacts as the temperature increases. So if you're going from 1 degree where you have some species are becoming extinct to where you have the higher temperatures, of course, where you're going to have much more extreme cases of people being displaced, you know, levels being much higher, the permafrost having been melted. Many countries might be underwater due to the increases in seawater because they're already low to begin with, and so on and so on. So obviously these impacts will be increasing as the temperatures increase. So it also changes things like the quality and the quantity of the water. Basically, we've seen obviously aspects related to the wind stresses, the sea level increases and so on, but it also can increase incidence of contaminated sediments and soils and so on, because you're going to have much more increase of the runoffs and so on, so which will have to be deposited elsewhere. So yeah, so many engineers know about, obviously, the UN sustainability goals. These are the 17 that have been derived. So you have many of them in different areas, things like soil, land management, water, and so on, are some of the key ones that we've been looking at. But as we've known, that particular engineers, maybe we find it a little bit difficult sometimes to be able to see, is it possible for us as engineers to do anything towards these goals? Because many times we think of it as like only a national thing, that maybe it's great for nations to think about these things and so on. But as engineers, there are definitely things that we can do. These are some examples that were coming from the World Federation of Engineering Organizations. So maybe I won't go through this whole graphic here, but maybe just to pick up a few of these aspects here. So things, obviously climate change, which we just mentioned. So if we can develop ways, obviously as engineers, for carbon sequestration, to reduce greenhouse gas emissions, things like that, really good. Things like if you want to look at in terms of making cities and settlements more resilient and sustainable, so we can improve the urban infrastructure, and we can look at ways to have a secure engineered systems that are going to be resilient and sustainable over the time. We can also look at restoring, of course, I mean, seeing we're doing a geoenvironmental topic here. We can talk about things like soil and restoring these degraded soils, and maybe producing better biofuels or other means of alternative renewable energies. So these are some of the examples where engineers can contribute. So in generally, as I mentioned, the World Federation of Engineering Organizations in 2013, they came up with a code of practice that engineers should adhere to, basically a sort of a code of ethics in terms of sustainability. So we should be aware of and understand some of the environmental aspects. So this pertains to everybody, not just the geoenvironmental engineering students or environmental engineering students. And we should try to incorporate these sustainable practices and issues as much as possible into the field of practice. So if we don't know, which is often the case there, maybe then we have to consult with other people who have more of these expertise in these particular areas. We should reflect some of the regional, local, and societal values in the work that we're doing. So to be able to take into consideration, particularly the local and community concerns. So, so things like the traditional and the cultural values, which I'm going to talk about a little bit later on, should definitely be incorporated into some of the discussion on different projects. The sustainability aspect should be incorporated as early as possible. So as you know, like if you're having a house that's been built in the 1960s, say for example, and you want to make it energy efficient, it's pretty difficult to kind of retrofit these things, because these things are not built from the thing. So it's sort of the same thing with the project, in that when you start the project, it's good to try to incorporate the sustainability aspects as much as possible, as early as possible. So the costs and benefits of environmental protection should also be considered and incorporated into the work. So definitely the economic side should be considered. Looking at the planning in terms of, I see looking at the planning in terms of the life cycle. So not only the specific project itself, the narrow particular project, but looking at a more holistic thing from the beginning of the project to the end of the project. And all sorts of other aspects around it. We should incorporate, obviously, the environmental, social, and economic aspects, the key pillars of sustainability. We should have an open and transparent engagement process for all the stakeholders, all the people who are involved in the project and are concerned with the project. The regulatory and legal aspects, of course, have to be adhered to. So there's nothing we can do about that, obviously. Sorry, just need water. And we'd also try to mitigate and, make sure that we know what the risks are, particularly in terms of climate change and things like this. Things will be changing as we go along. There's a lot of uncertainty and so on. So we got to try to implement these aspects as much as possible. So we've seen over the years sort of a change in how things have been viewed. Sort of like in the 1960s and so on, pretty much anything went. There was too much regulations in terms of the environment. By the time we got around to the 1970s, however, we started seeing incidences of contaminants getting into the environment, and some very there's a lot of problems in terms of health aspects and so on. So we started having regulations in terms of how much contaminants could go into the environment, usually through water treatment systems. In the 1980s, we started thinking a little bit more about waste minimization. In 1990s, we started thinking about life cycle assessment, and reducing the pollution to begin with. And then finally, in the 2000s, we started thinking much more about the sustainability. So trying to incorporate all of these environmental, social, and economic aspects, as well as the environmental. And we also we're starting to think about these life cycle assessments as ways of looking at doing these assessments as well. Just to give you the quick overview in terms of the life cycle, what we talk about, of course, the life cycle is the whole life of a particular material. So we're going to take an example, something like mining of copper or use of copper. So we're going to be obviously going to have to mine the copper. Then you'll have to do the refining of the copper in the factories, basically. And then, so if you wanted to make, say, for example, copper piping, so then that will be the next step. Once you do the refining of the copper, you would be doing all sorts of the transportation of these materials. Once they become pipes and things like this, to be used for the construction. So these also have to be transported, and have to be incorporated into, say, for example, a building. The building, of course, will, and with the piping in it, will be operating for several years. And then eventually what will happen is that you'll either change the piping or change the building, and there will be a demolition and so on. So obviously we want to avoid this path as much as possible, going into the landfill with no use more in sight, by doing as much of the recycling as possible. So this is sort of the whole concept of this cradle to grave. So when we look at the refining of the copper and into copper piping. Okay, so as we mentioned, we want to try to incorporate these aspects of sustainability into various processes, projects, cities management, things like this. But how are we actually going to determine whether actually what we're doing is more sustainable or not? So in this presentation, I will kind of go through some of the things that we can do to at least to try to measure or do some comparisons to see what we can do and how can we measure these aspects of sustainability. So just if you're just looking in terms of environment, indicators are pretty much the way to go to look at the sustainability of a particular city. So you need to be able to do some measurements. So say, for example, the costs and consumption of energies, how much renewable energy you're using compared to non-renewable energy, what aspects related to the biodiversity, what aspects, in terms of habitats and biodiversity, and maintaining their habitats. What are you doing in terms of water consumption? How much water per person, say, for example, is being used? How much pollutants are getting into that water? How much recycled water is actually being done? How much waste is being produced? How much recycling is done? How much, how many contaminated sites are there in that particular area? And so on and so on. And of course, for food, are you doing using agriculture or food production within the city itself? And of course, you have in terms of air quality, toxic emissions, what kind of emissions you have, what kind of greenhouse gas emissions you have, and what kind of transportation systems are being used, and so on. So yeah, so using indicators is one way about it. The Army Corps of Engineers in the US have come up with a sustainability checklist in terms of, so this is kind of is it integrated or not? So, have you considered design principles when you're doing your project? Have you gone about trying to optimize the energy uses? Are you trying to protect the water and look at ways of conserving the water uses? The indoor environmental quality, of course, it will depend on what kind of project you have. Are you minimizing waste materials and uses of materials that you have? are you trying to use green purchasing, as much as possible? And where are the facilities being sited and oriented, and how are the layout, size, and so on? So are these being optimized towards sustainability? So these are some of the aspects, and also stormwater management and so on is another aspect. So these are just checklists. So is it included or is it not? Oh, yeah, and sourcing and so on, and transportation of materials. So you want to try to minimize, obviously, the amounts of transportation that are used to get your materials, and try to use it as locally as possible, and so on. Okay. So yeah, so we've looked at definitely different types of tools for doing the reporting and rating tools. So there are various tools that are available. So I think probably most people are very familiar with the LEED that's used for buildings and so on. So, and that's the thing, is used mainly for building design and so on. So it includes all these indicators, and you can get various points for doing the different aspects. And so it depends on how much you can do with everything. So you have the environmental, social, and economic aspects. So the BREEAM is kind of the equivalent in the UK. The GRI is the Global Reporting Initiative. So it kind of gives you a prescription of types of indicators that you could use, but it doesn't give you exactly how to go about it. So there's no system per se in terms of doing the evaluations. Most recently, of course, in the ISI in the US is the Envision. So this is there are different projects have been evaluated using the Envision. So it includes many aspects of the environmental, social, and economic. So this just shows you to some extent some of the indicators for the environmental, and the sequel is pretty much the equivalent in the UK for doing these tools. Let's see, what else do I have next? Oops. Yeah, these are some of the social aspects, looking at the heritage aspects, looking at some of the human rights aspects, equity, culture, and so on. So in Canada, we've kind of, the Civil Engineering Society has adopted the Envision as well. So they are promoting the Envision use as much as possible in Canada. So which tool would you use? It depends on what type of project you have. Are you covering all the sustainable engineering aspects that you would like to cover? Are you able to evaluate the state-of-the-art processes? Are you able to set certain goals and achieve them using these softwares and rating tools? Can you compare your performance against a specific goal? Does it have a weighting system? So the weighting systems are used basically to get an indication of, or maybe, basically to make a differentiation to things that are much more important than another aspect. So if you figure something is much more important, you can give it a higher weight. So are the results consistent? So of course, the rating tools like Envision, you have to have an environmental professional do these evaluations, and so that helps to some extent. So they have the training of the Envision, the specific tool, and how to go about it. And these are independent people, so hopefully the results will be much more consistent than if not. Okay, so I just wanted to show a couple of examples where the Envision has been used. I hear a little bit of noise in the background, so maybe somebody can close their mic, please. Yeah, thank you. So yeah, so in Montreal, we had the Champlain Bridge that had demolished and rebuilt. It was a bridge that was supposed to have been lasting for about 100 years, but only lasted about 40 years. So they had to redo a new bridge. So they used the Envision to do during the design of the new bridge, and it received the Platinum Award. So this is a private public partnership of the federal government and us companies. And so some of the key factors of the particular project, looking at the sustainable growth and development for the commuters. So it's Montreal is an island, so there are different people who live in the off the island, come into the city, and of course you have all the goods that are transported back and forth across the bridge. So you want to be able to make sure all the trade and the commuters are sure that the quality of is supported. So many types of transportation had to be incorporated. So whether it be cycling, the train, the cars, buses, and so on. So all had to be supported. We also looked at, they also incorporated what kind of leadership and in sustainability could be obtained. So looking at all the different indicators for the economic and quality indicators. They wanted to make sure that the de-icing, of course, Montreal is a cold city, so de-icing is a major thing. So we want to make sure that we had a very good de-icing system for the bridge. And some of the other features were that you had a great stormwater management system that did take into account the upcoming climate change. They looked at offsetting the greenhouse gas emissions through carbon credits. They have a really fantastic lighting system, which I don't have here. Basically, the lights are programmed particularly to reduce any light pollution effects on migratory birds in engineering. And so they recently mentioned, of course, that certain colors are very attractive to migratory birds. So they've avoided these lights during the season, particularly now where all the birds are coming back from the south back into Canada. And of course, they had to be energy efficient. And there was very little construction waste. The construction waste was recycled quite heavily. There was very little, and as you see, there was only a very small amount was sent to the landfill, so which is great news. And what they also did was worked on the marshlands around the areas. They restored as much as possible, and they also made new spawning areas to reduce any loss of fish habitats and wetlands and so on in the particular area. So one more project that was done through this one, particularly using Envision Canada, which was done a little bit later. I think it was just posted last year. So basically there's a project in the municipality of York, which is in the Toronto area. So they got an Envision, I forget the rating, sorry, I forgot to mention it here. The rating for sustainability for this particular project. So the specific features that they had was incorporating an elevated wooden boardwalk to be able to go through the wetlands to not disturb the wetlands. They incorporated all sorts of benches, bike racks, and things like this in the meeting area. They had the pedestrian bridge, as I mentioned, basically to make sure that you protect the project area. They had all sorts of bridges and other aspects. They had an active rail corridor that was put in the project. They also put retaining walls that were obviously very functional, which were required, but they also made them aesthetically pleasing. So it looked like it incorporated all the tree patterns. And so it helped to improve the community attractiveness for the residents and for the trail users. And they also incorporated some cycling trails and so on in the area, which was the first time that had been done. Okay, so yeah. So yeah. Oops. Oh, okay. So yeah, so the if you want to look at sustainable redevelopment, so these are some of the infrastructure projects that we've been looking at. We're also looking at now in terms of restoration of lands and so on. So ideally, why is it moving? Okay, here we go. We got too many arrows here. So if you want to look at in terms of sustainable land management, obviously targeting lands that have already been used for another purpose are the best lands to use. Because if you're going to be cutting down trees, destroying wetlands and things like this is not a very sustainable track. So if the lands have already been disturbed, it's better to try to reuse those lands and then redevelop those particular lands. And so there are many advantages to that, in that you can be able to get to the tax base from using these lands back again. I mean, obviously there are going to be challenges because you have to do the contamination, things like this. You'll obviously have to do the restorations. You'll have to get the funding to be able to do these decontaminations, and you have to get the community involved and so on. So it is a complicated process, but obviously more sustainable in the long run. So if we're looking at remediation, of course is ability because you can reuse the land, but also the remediation process itself is actually sustainable. So there have been various initiatives within Europe in particular. The Clarinet with the Contaminated Land Rehabilitation Network, Nicole, the Euro Demo, and SURF, which is both in the US and in the UK, the Sustainable Remediation Forum. So these are some of the initiatives that are trying to promote sustainability in the remediation itself. So even in the US, as I say, you recently had the SURF conference there, which was in October in the East Coast for the health and safety, the environmental AES. So the US EPA, of course, they promote green remediation, which is not quite the same as sustainability, because the green remediation basically looks at the remediation in terms of making it as environmentally friendly as possible, and not necessarily incorporating the social and the economic aspects, which is the sustainable remediation. In Canada, you have basically the Federal Contaminated Sites Action Plan. And so this is a decision-making framework which does promote sustainability, but it's one aspect there. And then you have the Green Municipal Fund, which also will help to fund projects that also have some sustainability aspects in it. My computer is a little bit slow these days. Okay, there we go. Okay, I want to give a quick example of GoalSet, which is a sustainability evaluation tool by Golder Associates. It's now which is known as WSP right now. So many of these engineering companies. So actually, what I do is I use this tool in my class. So I give the class an environmental problem, and I asked them to do the remediation of that particular problem of that site. And I asked them to use this particular software to be able to do the evaluation of various options of the remediation. So this is the advantage of it. So you can have a bit of a yardstick to be able to compare the remediation techniques for this particular for a particular site. So you initially go through the first part. You do all of the characterization of your site. You identify your options. You develop then the indicators on the environmental, social, and economic basis. You do the scoring. These are done usually through discussions with your client and the different stakeholders in the project, and then you're waiting to be able to make a higher impact for the ones that are more important. And then following that, you do the compare your various options, and then you will do the recommendations based on those options and the results that you get. So just to give a quick run through of a case study, you have a benzene spill that occurred near a highway, near a small town due to a train derailment, which is unfortunately, this happens way too much. you have some benzene that gets into the groundwater, and the level of benzene is too high. And so the remediation will need to be done because that groundwater is used for drinking water. The affected site is about six hectares. So there are different options that are identified. So you do the pump and treat, out the groundwater, and then you do certain treatments, whether it's by activated carbon or by air stripping. You can do an in situ process of combination of biosparging and bioventing, or you can do the what people consider the nothing aspect of doing natural attenuation. So just monitoring what's going on at the site. So these are some of the indicators: the water usage, greenhouse gas emissions, things like this, quantity of waste, things like this. You can quantify these. So you can have both qualitative and quantitative indicators. These are the quantitative indicators that can be used. So you can have for the social aspects is how long is there public disruption because of the work, and some of the economic, the net present value of that particular work. So you can do, so these are some of the economic aspects, looking at the litigation aspects potentially, the corporate image, the technological uncertainty, and so on. And again, you can compare the different options. So you give them the score, and these are the weights that you would give that have been decided via the discussion. Some of the aspects. So water usage, soil quality, things like this. So they're within the tool itself. There are various descriptions so help to come up with the ratings. And these are some of the social aspects. So finally, it's as I say, this multi criteria tool, and you can come up with the different graphics at the end. So this is, you could also include in other aspects relating to technology itself in terms of the technology readiness and so on. So you can come up with a diamond instead of a triangle. But anyway, this particular one, they use just the triangle aspect. So looking at the environmental, economic, and social aspects. And as you see, what you're trying to attain is the more balanced process. So what's you know, the larger the triangle and the more balance that it has. So as you can see, the natural attenuation is probably the largest and the most balanced. But unfortunately, the disruption, as you'll see, will be the negative part would be the length of time the project would take. So like 20 years. So most often that's not really very acceptable in terms of the length of the thing. So maybe you want to go to the next more sustainable project, which is basically the biosparging, bioventing. So you see that the pump and treat obviously is not as sustainable as the biosparging, bioventing. So these are one type of tool that could be used for site remediation options. You could also look at the different disadvantages and advantages where each of the options is strong and weak. And you can do various adjustments, of course, and you can do your optimization of your process as well. There are other sorts of tools that are available. So DFI Sustainability Committee came up with this geotechnical carbon calculator. So this is another tool that's available. So this works usually looking at the carbon dioxide emissions, and you know, all of the different types of the work are converted into these emissions. This is an Excel-based process, it's easy to learn, so on. A lot of it's free to learn. You can download it. Anybody can download it, and it's certified for the greenhouse gas protocols. And so the different categories are the materials, the energy that's used, the type of transport that's used, the people's transport that's used, the assets, in terms of the different manufacturing parts, equipment, and so on, what wastes are generated or transported off-site, and kind of other emissions that are needed. So this is a quick example of that. I see my time is going here. Okay. Yeah, so I have a recent project that was done by Keller in New York. The ground improvement was selected by the client, had various rigid inclusions. They did a carbon calculator based on the original design, so without making any changes to the process. And then what they did was they tried to see whether they could reduce the carbon footprint. And so what they did was they worked with a supplier for the grout, and they come up with a different grout mix design there that kind of reduced the carbon the embodied carbon in the process there. So as you can see, this is the amount of equivalent carbon dioxide before, and then this is after the process there. So you see that there's basically 1,000 tons of carbon dioxide equivalents that have been achieved just by optimizing the grout mix that was used. Okay, so we'll look at a couple other processes. One other process looking at conventional techniques in terms of soil stabilization. So using cement, using various binding agencies, using various pilot foundations and different types of drainage systems to be able to improve the ground functionality. So there are a number of natural processes that are going on. Basically, this diagenesis in the soil, basically in the formation of the soil, you have these natural carbonates that are formed during the natural soil processes. So what has been done is to take advantage of these processes. These are just some examples from a bentonite mine. You can see kind of the carbonate nodules in the, I don't know, maybe a little bit difficult to see in this, but see some of the carbonate nodules that are in the bentonite there. So so basically, if we could speed up this process, that would be good. And this is what kind of has been done by trying to look at using some of these ureas processes, basically, that form the carbonates there. And then with the calcium and the magnesium and with the carbonates there, then you can form this precipitate that can help to stabilize the soil to some extent. So that's exactly what's done by using these microbial induced carbonate precipitation. The MICP process is kind of a developing process that's been done now. So this is kind of thing, you have your bacteria, you cultivate them, you inject them, and then you make sure that you have enough of the nutrients and the calcium and magnesium in the site there to be able to do the stabilization. So this gives a bit of an example of injection into sand. So you can see that the sand is actually able to stand up after this process. And of course, you can see as you increase the carbonate content, you can see that the unconfined compressive strength is also increasing. And you can see again, as the carbonate increases, that your the dynamic cone penetration at before the stabilization and after, you can see the improvement. So of course, this can be done by injecting these mixtures into the soil, into a very soft soil, so that you can help to do stabilization. So my collaborator in Japan actually has formed a company to be able to exploit this technology. And I just wanted to mention about this concrete canvas. It's another collaborator I have, in environmental containment. So they have what they call this concrete canvas, which is basically a combination of geosynthetic and with the concrete in the middle, basically. So it's soft to begin with. You add water to it when you have it rolled out, and then it becomes very hard, and you can use it for basically stabilizing all sorts of situations, whether it be culverts, soil reinforcements, channel linings, and all sorts of things like that. So the advantage of this is that you can save the transport, obviously, with all the concrete. And so basically the carbon footprint is much, much lower for this type of process system. So, oops, sorry. So just to go back for 1 second. So as you see, if you get for a square meter of channel lining, you can have a 55% less embodied carbon in this type of material to poured concrete. And I think the last topic, oops, sorry. Oh, sustainability strategy. Okay, my time is going here, I see. Anyway, okay, so just a couple of examples of sustainable practices. There's the London Olympics. You look at the prevention of the environmental aspects adverse. So they when they were doing the development of the London Olympics in 2012, they made right from the beginning that they wanted to be able to minimize the impact on the environment as much as possible, prevent accidents, provide social and economic benefits, reduce waste and recycling as much as possible. So they, from the get-go, they decided to do that. So they have many targets. These are just a few examples of some of the targets there to reduce the carbon emissions. So finally, they were able to do that by about 86%. The venue footprint, they reduced that by 47%. You know, things like improvement of air quality, that was very good. They reduced that by about 90%. The difficulties they had were in terms of reducing or making sure that they use as much recycled materials as possible. They found this was very difficult because you had to work with the suppliers, and often some of the suppliers don't know what's in the materials and things like this. So this was a very, very hard one to obtain. Other things like reuse and recycling, they were able to easily do. But as I say, when you had to get other information, sometimes it was not so easy. So some of the procedures that they did was they came up with a working group from the beginning. They developed guidance procedures. They worked with the suppliers to review the products and materials as much as possible. They reduced the need for some ventilations and cooling, tried to make more natural process as much as possible. They designed various modules to reduce the waste. So some of the lessons learned, they had a very clear vision and approach right from the beginning. They realized that it was a strategic approach was needed to develop this approach for sustainability because it was not a usual practice. They needed to prioritize various targets. They had design teams and suppliers, and everybody needs to be engaged and work together to be able to improve the performance. This was where some of the difficulty was. Some of the suppliers were not well adverse in some of the practices of sustainability. So some of the suppliers had to learn new things. And so more support is needed to the supplier sometimes. And this was probably where the most difficult aspect of the sustainability was to obtain. And so although they learned, so there was many lessons learned. So although this is a unique event, because you're running the project is at one time, but it obviously project, and they also use this, well, as you remember, this is the UK version of the Envision to optimize these material uses and energies as much as possible. So it's a very successful project. So the last topic, which I'll go very quickly, is the social sustainability, and basically mentioning about renewing the relationship with Indigenous peoples. So in Canada in particular, we've had a very bad past. Since about 2016, the paradigm has been shifted quite thankfully, not fully successfully, but at least it's on the right path. And so now there's much more commitment to have a meaningful consultation with Indigenous peoples on various projects and so on, and to give them access to the jobs and training and education that they really need to be able to be sustainable in the long term. So engagement is different than consultation. So basically it means a process where there's a confirmed interaction between the communities and so on, not just like, okay, is this going to be okay or not, right from, during the process towards the end, but right from the beginning, you have a consultation and a discussion with the communities as much as possible. So there are obviously many challenges that the community is facing, things like water quality, buildings, maybe some lack of training sometimes. Some of the impacts of climate change are going to be much more pronounced, particularly those in the northern communities. They do have resource capacity challenges to some extent, but on the other hand, more funding and much more experience now from the Indigenous communities, and much more will by the communities to be involved and so on. So basically, you have to learn, contact them as early as possible and learn from the, who are the people to talk to, who are the key people in the communities. Of course, usually the elders and keepers are the ones to start with. So identify their capacity, see what roles that they have, what can be done. There are many training organizations that are available now, and working with local Indigenous firms and community companies and things like this are great ways to go about it as well. So effective engagement basically means treat them as partners and rights holders and not stakeholders. And then the other key message that I wanted to mention is make sure that to start the engagement as early as possible. And then there's an open process, and definitely the lines of communication are open. So many challenges, but again, many solutions now. There are different examples of engagement that have been done in many of these projects, these are in Canada. But really what I wanted to show is basically the engagement, as you see here, is right from the initial contact and all through the project. So this is just the generic, an example of a particular project. But as you see, the engagement is to be all through the project, not only at the beginning or the end. So this is a very good project now that's going on in the Ottawa area. It's under work. So they're going to be developing housing areas and so on. And so there's like an Algonquin benefits plan that's being developed as part of the project. So finally, I just wanted to mention my concluding remarks is basically that there are some improved tools that are now available for design. Sorry, my voice is going. I think in many cases still there's a lot of policy and initiatives that are needed to promote these incorporation of sustainability in the projects. Obviously, various partnerships are needed to ensure that they definitely are sustainable, such as working with the local communities. Maybe you have to work with many different types of engineers to make sure that everybody works together. Yeah, again, local communities engagement is definitely essential, particularly Indigenous communities. And being a researcher, of course, I always mention that you need research in different areas, particularly some of the impacts of climate change and how to develop novel solutions to mitigate the climate change and to manage and to get around it, to adapt to the climate change. And I guess the final aspect that I wanted to highlight was basically that engineers are usually undervalued, but they're really critical for developing solutions for climate change and how to adapt to climate change. So I wanted to thank you very much. These are just some plugs for some of the information that's come from the different books. My book on sustainable engineering, natural attenuation, sediment remediation, and one more. Oh yeah, the third one is on the sustainable practices in geoenvironmental. This is the book I use for my course. And right now we are actually working on the third edition of this book. So any case studies are great to be able to incorporate into this book. So I thank you for your attention. So I will stop sharing at this point, and thank you. And I will entertain any questions if there's particular time. I realize that my time went very quickly.
No, thank you. Thank you so much, Catherine, for very comprehensive presentation. So